In this video, we are going to cover 9.3 Preparation. At the end of the lesson, students should be able to explain the preparation of carbonyl compounds through ozonolysis of alkene, Friedel-Crafts acylation to produce aromatic ketone, and oxidation of alcohol. Carbonyl compounds can be prepared through ozonolysis of alkenes, Friedel-Crafts acylations, and oxidation of alcohols. First, we'll look at the first method, ozonolysis of alkenes. Ozonolysis of alkenes produce aldehyde or ketone or both. General reaction is as follows. We have an alkene. If this alkene undergoes ozonolysis with O3 followed by zinc and H2O, we will get ketone and aldehyde. It is fairly easy to predict the product of an ozonolysis. If we have an alkene, we just split the carbon-carbon double bond, and each carbon double bond will end up with oxygen. So we will get two carbonyl compounds. The R group and hydrogens stays the same. The substance zinc H2O can be substituted with CH3,2S. Look at the following example. The first one, we have an alkene with R group and hydrogen both on the left and right side of the carbon-carbon double bond. If this alkene undergoes ozonolysis, we can split up the carbon-carbon double bond, and each carbon-carbon double bond end will attach to oxygen. Since there is a hydrogen on the left side and the right side of this alkene, the product will be both aldehyde. The second example, the alkene does not have any hydrogen. They are all 4 R groups. If this alkenes undergoes ozonolysis, we can split the carbon-carbon double bond, and each carbon-carbon double bond will end up with oxygen. Since there is no hydrogens, both the products will be ketones. The next example, we have a cyclohexene. If this cyclohexene undergoes ozonolysis, we can split the carbon-carbon double bond, and the cyclohexene will lose its cyclic shape. Each carbon-carbon double bond of the cyclohexene will now become an open chain with carbon double bond to oxygen on both ends. The number of carbons for the open chain shape is still the same as the number of carbon in the cyclohexene shape, which are 6 carbons. The next example, we have carbon-carbon double bond with hydrogen on the right side. If we split up the carbon-carbon double bond, each end will end up with oxygen, and we will get two products. The left side will form a ketone, while the right side will form an aldehyde because the right side has hydrogen. The second method is Friedel-Crafts acylation. This is a good method to prepare aromatic ketones. The reagent used are acyl chloride in the presence of a Lewis acid, such as FeCl3, FeBr3, AlCl3, or BF3. General reaction is as follows. If we have a benzene ring reacts with acyl chloride in the presence of a Lewis acid such as AlCl3, the hydrogen in the benzene will be substituted by the carbonyl and R group from acyl chloride. And as a result, we will get an aromatic ketone. The third method is oxidation of alcohol. Aldehyde can be prepared by oxidation of primary alcohol using PCC, which means pyridium chlorochromate in dichloromethane. General reaction is as follows. If we have primary alcohol undergoes oxidation with PCC in CH2Cl2, we will form an aldehyde. Oxidations of secondary alcohols using any oxidizing agent will yield a ketone. General reaction is as follows. If we have secondary alcohol undergoes oxidation with acidified KMnO4 in heat, we will form a ketone. KMnO4 can be substituted with K2Cr2O7. For example, if we have a primary alcohol which undergoes oxidation, the hydrogen attached to the carbon and the hydrogen attached to the oxygen will be eliminated, and the product formed is an aldehyde. If we have secondary alcohol, the hydrogen attached to the carbon and the hydrogen attached to the oxygen will be eliminated, and the product will be a ketone. In summary, there are three methods to prepare carbonyl compounds: ozonolysis, Friedel-Crafts acylation, and oxidation of alcohols. That's all for this video. Thank you.